Section 15A, Question 4, page 363. This question asks us to find the gradient of the tangent of a certain number of functions at a variety of values. The first one is y equals x squared at x equals 2. So to find the gradient function, first we need to find the derivative. So we will find dy by dx, and that is 2x. And then if we want to find the gradient, I use m to represent that, and that is the derivative evaluated at x equals 2. And then we know that we take this 2x, we substitute 2 into x, and that gives us 4. So the gradient of y equals x squared at x equals 2 is 4. Part B, y equals 8 over x squared at the point 9, 8 81sts. So I'm going to rearrange this to make it 8x to the negative 2. And now I'll take the derivative of this, dy by dx. That gives me negative 16x to the negative 3. And now to find the gradient, I'll evaluate dy by dx at x equals 9. And so I take this gradient function, negative 16x to the negative 3, and I substitute 9 into that, which gives us negative 16 times 1 over 729, because 9 to the negative 3 is 1 over 729, which then gives me negative 16 over 729. So therefore, the gradient of 8 over x squared at the point 9, 8 81st is negative 16 over 729. I'll look at part C. The function is y equals 2x squared minus 3x plus 7, and we're evaluating the gradient at x equals negative 1. So the gradient function, dy by dx, is 4x minus 3. And when I evaluate dy by dx at x equals negative 1, I see that I substitute negative 1 into x, into the gradient function, and I get negative 7. Part D, y equals 2x squared minus 5 over x, and we're evaluating the gradient of that function at the point 2 and 3/2. So I will rearrange this first of all and simplify it a bit. So I'll break up the denominator into 2. So I'll make 2x squared minus 5 over x into 2x squared over x minus 5 over x. Simplify this, so I get 2x minus 5x to the negative 1. Now I'll find the derivative of that, which gives me 2 plus 5x to the negative 2. So I bring this negative 1 down in front to multiply by negative 5 to give positive 5. Subtract 1 from negative 1 to get negative 2 for the exponent. And then that becomes 2 plus 5 over x squared. And if I really wish to, I could change this. I would multiply top and bottom of this by x squared. So I get 2x squared plus 5 all over x squared. Just to have a neat, tidy little function, all over x squared. And when I evaluate the gradient, or when I calculate the gradient, I evaluate dy by dx at x equals 2. And that gives me 2 plus 5 times 2 to the negative 2. I put it back to this original form here just to evaluate it. And so I get 2 plus 5 over 4. 2 in terms of a function or a fraction with denominator 4 would be 8 over 4, because this is 2 over 1. and 8 over 4 plus 5 over 4 gives me 13 over 4. So the gradient of this function, evaluated at this point, is 13/4. In part E, the function is y equals x squared minus 4 all over x squared, and we're evaluating the gradient of that curve at 4 3/4 at that point. I'll rearrange this again, so x squared over x squared just gives me 1 minus 4 over x squared, and I can rearrange that, or rewrite that to be 1 minus 4x to the negative 2, so I can find the derivative function, or the gradient function, a little bit easier. So the derivative of 1 is just 0, and then the derivative of negative 4x to the negative 2 is positive 8x to the negative 3, which could be written as 8 over x cubed. And then when I determine the gradient, I evaluate the derivative at x equals 4, which gives me 8 over 4 cubed, which is 8 over 64, which gives me 1 over 8. And for part F, the function is x cubed minus 4x minus 8 all over x squared. We're evaluating the gradient of that curve at x equals negative 1. So I'll rearrange this. So x cubed over x squared is just x. Negative 4x over x squared is minus 4x to the negative 1. And negative 8 over x squared is negative 8x to the negative 2. Now I find the gradient function by differentiating this. So the derivative of x is just 1. The derivative of negative 4x to the negative 1 is positive 4x to the negative 2. And the derivative of negative 8x to the negative 2 is positive 16x to the negative 3. I can then rearrange this if I so choose. So it'll be 1 plus 4 over x squared plus 16 over x cubed. And then write it all over the same denominator, which would be x cubed. So I have x cubed plus 4x plus 16 all over x cubed. Now when I determine the gradient, I take the derivative function, or the gradient function, and I evaluate that at x equals negative 1. And so that gives me negative 1 cubed plus 4 times negative 1 plus 16 all over negative 1 cubed. And so that gives me negative 1 minus 4 plus 16 all over negative 1, which gives me a grand total of negative 11. So the gradient of the tangent to this function when evaluated at x equals negative 1 is negative 11.